Question 3 says that ABCD is a rectangle and PQRS are the midpoints of the sides of the rectangle AB, BC, CD and DA. So here's a figure I've drawn for you. ABCD is a rectangle. You can see that PQRS are the midpoints of the sides of this rectangle and they are joined. And we have to show that the quadrilateral formed PQRS is a rhombus. So this is kind of similar to question 2 of this exercise. In question 2, the midpoints of a rhombus were joined and the resulting quadrilateral we had to show was a rectangle. In this case, it's the other way around. The midpoints of a rectangle are joined and we have to show that the resulting quadrilateral is a rhombus. Now, to prove this fact, we will use the result we proved in question 1 of this exercise, where we proved that if you join the midpoints of the sides of a quadrilateral, you get a parallelogram. So I'm going to prove that result briefly here, but if you want to understand it in detail, you can go back to the video of question 1 and watch it again. So we will start by proving that PQRS is a parallelogram, and to do that, all we need to do is to draw one diagonal of the rectangle. So let's draw the diagonal AC. And then we will study the relationship of PQ with AC and RS with AC. So first, let's see how PQ is related to AC. So if you take the triangle ABC, observe the triangle ABC and apply the midpoint theorem to triangle ABC, P and Q are the midpoints of AB and BC. So using the midpoint theorem, we can claim that PQ is parallel to AC and PQ is equal to half of AC. So PQ is equal to half of AC. Similarly, if you apply the midpoint theorem to triangle DAC, so S is the midpoint of DA and R is the midpoint of DC. So we have SR is parallel to AC and SR is equal to half AC, again using the midpoint theorem. So from these two relationships, we can claim that PQ and SR are parallel to each other. So PQ is parallel to SR, and also PQ and SR are equal to each other as well because both are equal to half of AC. So PQ is equal to SR as well. And this means that in quadrilateral PQRS, one pair of opposite sides are parallel and equal. So PQRS is a parallelogram. Okay, so this is how we prove that PQRS is a parallelogram. Now all we need to show is that the adjacent sides of this parallelogram are equal, and that will mean that PQRS is also a rhombus. To prove that, let's draw the other diagonal also, the other diagonal BD also. Now I want you to think about the relationship of the other two sides of PQRS with BD. So think about the relationship of PS with BD and think about the relationship of QR with BD. So let's think about the relationship of PS with BD. So to do that, we will apply the midpoint theorem to triangle ABD. So ABD is this triangle that I am highlighting now. In this triangle, P is the midpoint of AB and S. So P is the midpoint of AB and S is the midpoint of AB. So by the midpoint theorem, we have PS is parallel to BD and equal to half of BD. So PS is equal to half of BD. Okay, now we just need to focus on the fact that PQ is equal to half AC, PQ is equal to half AC and PS is equal to half BD. But in a rectangle, we know that the diagonals are equal. The diagonals in a rectangle are always equal. So in ABCD, because this is a rectangle, AC is equal to BD. And this means that because AC is equal to BD, this means that PQ and PS must also be equal because they are half of AC and BD respectively. So PQ must be equal to PS. So what we now have is a parallelogram PQRS in which the adjacent sides PQ and PS we have shown as equal, and this means that PQRS must be a rhombus. So from here we can conclude that PQRS is a rhombus, and this completes our proof. So to summarize once again, first, in the first part of the proof, we proved that Pqrs is a parallelogram, and this is something we had done in question 1. I just recapped that in detail here, in brief here. If you want to see it in detail, you can go to the video of question 1. So first we proved that Pqrs is a parallelogram, and then we proved that the adjacent sides of Pqrs are equal. And how did we do that? Well, PQ is equal to half of the diagonal AC of the rectangle, and PS is equal to half of the diagonal BD of the rectangle. And then we use the fact then that in any rectangle the diagonals are equal, and hence the adjacent sides of PQ, the adjacent sides PQ and PS are also equal. So Pqrs is a rhombus. So this completes question number 3. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.